Today's lesson is about error. We've started. We have already looked at error earlier in this topic, but we're particularly going to look at how error would affect, how the error in a measurement would affect your area and your volume calculations. So we already know about error when we're taking a measurement. If I was measuring a distance and I measured it as 3.1 metres, what do we know about that? So say for example, I'm measuring this particular rectangle. I measure this to be 3.1 metres. I measure this to be 4.2 metres. Okay? Now I know there's some error, Aaron. I know there's some error in that. What range must the 4.2 lie within? So my precision,
0.1 difference.
it's 0.1 difference, so the error is a half of that. So it's 4 point up to 4.25. Is everyone happy with that? Because we've already done this. We're seeing how it applies to error and volume, okay?
Are you looking at that when you're answering my question?
What are we doing with that thing, is what I'm looking at. Yeah, because it's really annoying me. I think you should put it away. Yep. This one here, what's this line between? 3.05 up to 3.15. So that is not new. We've done that before. We understand how that works. What that then affects is if I want to calculate the area of this shape, then I can work out
Seriously? Next door.
Is it?
Yeah.
Okay, so what is the smallest, what's the smallest this rectangle could be if I'm calculating the area? So what's the smallest area?
12.75.
Would equal 4.15 times 3.05.
12.75 short.
Who calculated that?
12.65. True. No, that's 2.75 short.
12 points, so let's give that to two decimal places. What would it be? 12.66? Okay, what's the largest the area could be? So 13.39. So if you need to calculate how much your error is in the area, you actually have to go back to the original measurements, look at the range that is possible for your original measurements, and then use those to calculate your smallest and your largest area. Is everyone happy with that?
Yep.
And so we know, even though if we multiply these, 4.2 times 3.1, we get, what's that, 4.2 times 3.1, we get our measured area as 13.02. Oops. Okay, so even though that is our measured area, we actually know that it lies anywhere between 12.66 and 13.39. If you are doing volume, it's exactly the same effect. You go back to the original measurements, you work out the range. The smallest it could be is when you use all the smallest measurements, and the largest it could be is when you use all the largest measurements. Does that make sense? All right, you guys can try a question.
We're going to do the same thing.